Hi all, I'll be talking about Chapter 6, Big Data and Analytics today. The learning outcomes from this chapter are: discuss what big data is and how it is changing the world of analytics, discuss the motivation for and business drivers of big data analytics, develop familiarity with the wide range of enabling technologies for big data analytics, discuss about Hadoop, MapReduce, and NoSQL as they relate to big data analytics. Recognize the role of and capability skills for data scientists as a new analytics profession. Compare and contrast the complementary issues of data warehousing and big data. Develop familiarity with the vendors of big data tools and services. Recognize the need for and appreciate the capabilities of stream analytics and discuss about the applications of stream analytics. Now we'll look for what is big data. Big data means different things to people with different backgrounds and interests. Traditionally, big data means massive volumes of data. For example, data collected from NASA, Google, etc. Where does it come from, the big data? It comes from everywhere, from weblogs to RFID to GPS systems to sensor networks, social networks, text documents, internet search indexes, call records, different fields of astronomy, biology, nuclear physics, scientific research, military surveillance, you name it. We will next look at the data size. Starting from kilobyte, which is 10 to the power 3, to megabyte, which is 10 to the power 6, gigabyte 10 to the power 9, terabyte 10 to the power 12, petabyte 10 to the power 15, on and on. So the data size is getting bigger and bigger. Next we will talk about the V's of big data. First one is volume, then variety, velocity, veracity, variability and value proposition, and we will talk about each of them. All these V's, they define the big data. Volume means the amount of data. Variety means data in all types of formats: email, video, audio, text, XML, etc. Velocity means how fast the data is produced and how fast the data must be processed. Veracity refers to accuracy, quality, truthfulness and trustworthiness of the data. Variability is next. It refers to the high inconsistencies of data flows with periodic peaks. And then the value proposition. By analyzing big data, organizations can gain greater business value. So, big data by itself, regardless of the size, type or speed, is worthless. You have to get value out of it by doing big analytics. And with the value proposition, big data also brought about big challenges. For example, effectively and efficiently capturing and storing and analyzing big data, and also we need new breed of technologies for being able to analyze such huge volume of data. Next we will be talking about some critical success factors for big data analytics. First, we need a clear business need, then strong, committed executive sponsorship, alignment between the business and the IT strategy, a fact-based decision-making culture, a strong data infrastructure, the right analytics tool, and we need the right people with the right skills. And next we will be talking about some enablers of big data analytics, such as in-memory analytics, in-database analytics, grid computing, and massively parallel processing and appliances. As the size and complexity increase, the need for more efficient analytical systems is also increasing. In order to keep up with the computational needs of big data, a number of new and innovative computational techniques and platforms have been developed. These techniques are collectively called high performance computing, which includes in-memory analytics, in-database analytics, grid computing, and appliances. In-memory analytics solves complex problems in near real time with highly accurate insights by allowing analytical computations and big data to be processed in memory and distributed across a dedicated set of nodes. Then in database analytics speeds time to insights and enables better data governance by performing data integration and analytical functions inside the database, so we won't have to move or convert data repeatedly. Grid computing promotes efficiency, lower cost, and better performance by processing jobs in a shared, centrally managed pool of IT resources. And appliances brings together hardware and software in a physical unit that is not only fast but also scalable on as needed basis. Some of the challenges of big data analytics are data volume, as we all understand. The ability to capture, store and process the huge volume of data in a timely manner is a challenge. Data integration, the ability to combine data quickly and at a reasonable cost. Then processing capabilities, the ability to process the data quickly as it is captured, which is also called stream analytics. Data governance, which involves security, privacy and access. Skill availability of a data scientist and the return on investment. So these are some of the big data analytic challenges. Okay, some of the big data technologies, MapReduce and Hadoop. These are the two big players in data technologies. Then Hive, Pig, HBase, Bloom and etc. They also play their roles. MapReduce distributes the processing of very large data files across a large cluster of machines processes. Goal is achieving high performance with simple computers. This is developed and popularized by Google. This is good at processing and analyzing large volumes of multi-structured data in a timely manner. Example tasks would be indexing the web for search, text analysis, graph analysis, etc. Hadoop. It's an open source framework for storing and analyzing massive amounts of distributed unstructured data. It was originally created by Doug Cutting at Yahoo. Hadoop clusters run on inexpensive commodity hardware, so projects can scale out inexpensively. And Hadoop is now a part of Apache Software Foundation, which is also open source. So because it is open source, hundreds of contributors are continuously improving the core technology. So MapReduce plus Hadoop, they are the big data core technology. Next we will talk about who is a data scientist. A data scientist is basically a big data guru, one with skills to investigate big data. Generally they get very high salaries with very high expectations. You can be a data scientist if you have a PhD in MIS or computer science. Some schools now have programs in big data also. Okay, next we will be looking at some of the big data vendors. A representative list would be Cloudera, MapR, then also IBM, Oracle, Microsoft, Amazon, Google. They are all big data vendors. SAP has its own big data also. They are all big data vendors. 10 top 10 big data vendors with primary focus on Hadoop. You can see MarkLogic, Cloudera, Tengen, MapR, Hortonworks, DataStax, Basho, Couchbase, Aerospike, Neo Technologies. These are some of the top 10 big data vendors. Lastly, we will talk about stream analytics. Data in motion analytics and real-time data analytics is called stream analytics. One of the V's in big data is velocity, speed, analytic process of extracting actionable information from continuously flowing streaming data. And why stream analytics is important? Because it may not be feasible to store the data because you may lose its value. Okay, you may lose its value. It has to be while in motion. And some of the stream analytic applications are in e-commerce, telecommunication, law enforcement. This is real-time data analytics, not storing the data and then later on analyzing it. This is analyzing the data as it happens, as it is produced. In power industry, in financial services, health services, and government. This is essentially your chapter 6.